Hi everyone, Darren here with your Week 4 wrap-up. This week you were asked to explore several statistical computations utilizing SPSS. These included frequency distribution tables, histograms, measures of central tendency and dispersion, specific scores and where they're located within a range or percentile rank, calculated skewness scores for a variable, and how to convert raw data into corresponding z-scores. Since we had a handful of questions regarding skewness, let's briefly readdress this topic. Visually, when we observe for skewness, we're looking for a lack of symmetry or lopsidedness that deviates from the normal bell curve. This can be observed in the picture above. You'll notice in the top diagram, each of the tails are symmetrical. They mirror each other, as one half of the scores fall to the right of the mean and the other half to the left. This indicates that our data set creates a normal distribution. Let's take a look at the positively skewed diagram on the lower right. You'll notice that data sets that have a positive skew will have a longer tail on the right side as opposed to the left. The median and mode scores in this type of curve will fall to the left of the mean. This indicates a lower number of occurrences at the high end of the distribution. For example, this may be the case when a difficult written test is given to a group of students. If a test is harder, we would expect to see fewer high scores. These high scores would be located to the right side of the mean or in the right tail, in comparison to lower scores, which we would see to the left side of the mean or in the left tail. This would result in our curve being lopsided because we're observing less scores in the right tail and more in the left. The opposite would be true for a negatively skewed distribution. When we have the median and mode to the right of the mean, this places more occurrences in the right side of the tail as opposed to the left, thus creating a negatively skewed data set. An example of this would be creating a written test that was too easy for a class, resulting in a greater occurrence of higher grades in comparison to lower ones. Quite often, simply determining skewness by observation alone can be tricky. Dr. Kappert reminded us in his forum replies that one of the primary assumptions or criteria for using hypothesis testing on sets of data is that the data must be composed of a normal distribution. Since it's a rare occurrence that data sets will be perfectly normal, we use the skewness score to judge the degree of skewness. Let's take a look at the rule of one. The rule of one refers to a criteria that is commonly used to judge an acceptable skewness score. If the score for a data set is between plus or minus 1, then it is considered normally distributed. If the score is beyond plus or minus 1, then the data is not considered normal and is not appropriate for parametric data analysis. We can also use the double SE method. This is a more common way we can check for normal distribution by examining the standard error of skewness statistic. To perform the double SE method to check for skewness, take the standard error of skewness statistic and double it. If the skewness score exceeds the double SE score, this would indicate that the distribution is skewed. Let's move to the next slide and go through an example. We have some BMI and systolic blood pressure data here in example 1. Let's determine if the two data sets are skewed, and if they are, which direction the skew takes place. Using the rule of one technique, again, if the skewness score for a data set is between plus or minus 1, then it is considered normal. If the score is beyond plus or minus 1, then the data is not considered normal and is not appropriate for parametric data analysis. In example 1, the skewness scores for BMI and systolic blood pressure are 0.981 and 1.148 respectively. Using the rule of one, we can confirm that the BMI data set has an acceptable skewness score since it does not exceed the value of plus or minus 1. For systolic blood pressure, however, our skewness score is 1.148. This score exceeds plus or minus 1 and therefore we would conclude that this data set is skewed. Since 1.148 is a positive number, our skew will be positive. The double SE method is a more common way to examine for distribution skewness and is also more conservative in comparison to the rule of 1. Let's apply this calculation to the BMI data set. We'll take the standard error of the skewness score for the BMI group and double it. This gives us a product of 0.074. Our skewness score of 0.981 exceeds our doubled SE value, and we can therefore conclude that this data set is skewed. This will be a positive skew since 0.981 is a positive number. If we apply the double SE principle to the systolic blood pressure group, we'll see that the double SE is calculated at 0.074. Since the skewness score of 1.148 exceeds 0.074, we can conclude that this distribution is skewed. 1.148 is a positive number, thus making the skew positive. I've included an additional practice problem for examining dataset skewness. This data output represents information gathered on a health history survey for a group of factory workers. At this time, determine the following. First, using the rule of 1, is this dataset skewed? If so, which direction does the skew take place? Second, using the double SE method, is this dataset skewed? And if so, what type of skew do we have? Please take a moment and pause this PowerPoint and calculate your answers. Okay, you've calculated your answers. Using the rule of 1, the skewness score of 1.612 exceeds plus or minus 1, and therefore we state that the data set is skewed. 1.612 is a positive number, thus making the skew positive. Using the double SE method, when we double the SE of 0.427, we get a product of 0.854. Our skewness score of 1.612 exceeds the double SE product of 0.854, and we can state that this data set is skewed. Since the skewness score of 1.612 is a positive number, the skew will be positive. Prior to concluding this PowerPoint, several of you mentioned on the forum you're nervous or have reservations with the material so far. This is perfectly normal. During your on-site session, Dr. Capper will provide a great deal of guided in-class activities that will slowly begin to take the intimidation away. He uses a step-by-step approach to teach statistics as a process rather than a series of complex mathematics. So this concludes our Week 4 wrap-up. I'll leave you at the bottom of the screen with this humorous YouTube clip that takes on the topic of skewness. Keep up the good work, and let us know if you have any additional questions.